You've got two main types of numbers, and that is integers or whole numbers and floating point numbers or numbers with a decimal place. For example, if we do age equal 35, this is an integer. And if we do pi equal 3.14159, this is a float. Notice that the variable name itself is largely irrelevant in this explanation. What matters is the value. Here we've got a whole number, a number that doesn't have a decimal place. And here we've got a number with a decimal place, so this is a float. Anywhere in Python, you can also use the hash symbol to write a comment. So here we have something called a integer, and here we have a float. And what happens is when Python goes through this code, it ignores everything that comes after the hash symbol. So you can use it to write comments for yourself, to remind yourself of what things are, or as notes for studying later on. Mathematics works just as normal. So we can have a variable called maths operation and make it equal to 1 plus 3 times 4 divided by 2 minus 2, making use of all the major mathematical symbols. And just as in normal maths, the PEMDAS or BODMAS rules are followed. So multiplication is evaluated first, then division, then addition, and then subtraction. So here we would have 12 divided by 2 is 6, 1 plus 6 is 7, minus 2 is 5. And you can verify that by printing it out. So I'm going to press run now, and we'll see 5.0 gets printed out there. This is an important part of mathematics in Python because whenever you do division, you always get a float. Even if the result is essentially something 0.0, which is basically a whole number, you always get back a float. So if we do something like float division and we say 12 divided by 3, then we print it out. And I'm just going to delete this code here for simplicity. So if we do something like this, you'll see that we get 4.0 back. If you want to get rid of the floating point or the decimal place, you can do integer division. So here I'm going to create a new variable called integer division. You can call it whatever you want though. Remember, these are just names. And I'm going to do 12 divide 3. And what this does is it performs a division and then removes everything after the decimal place. So this can come in handy at times. So if we run that, you'll see that you get 4.0 first from this first print statement, and then just 4 for the second one. Notice that if we change this to 8 divided by 3, the floating point division is 2.6, but the integer division is 2. This here does not round the numbers up and down. It just removes everything after the decimal place. So this is something to keep in mind as you do integer division later on. That's everything for this video. Thank you for joining me. Remainder of a division. And that is going to allow us to find out whether a number is odd or even. And that itself has a number of uses in programming. So let's get started. I'm going to create a variable called integer division and make it equal to 13 divide 5. Remember that when we do integer division, what we're doing is we're performing normal division, so 13 divided by 5, which gives us 2.6, and then we're dropping everything after the decimal place, so that means we end up with 2, because 5 goes into 13 twice. If we print this out, then you'll see that the print output is 2. Now, if we wanted to get the remainder of the division, which is 3, then Python gives us a nice way of doing that with the modulus operator. Let's get the remainder of this division by doing 13 modulus 5. Notice that this modulus operator is the percent symbol. When you do 13 modulus 5, Python will divide and then calculate what is left over. So if we print the remainder, then you'll see that the output will be first 2 and then 3. There you have them. So again, if we want to find out whether a number is odd or even, we can use the modulus operator. Have a look at these numbers and see if you spot a pattern. We've got the number 10, 14, 6, and 340, all of them divided by 2. What would the remainder of this division be if we evaluate it? And for all of these numbers, which are all even, the remainder of division by 2 is always 0. That is what characterizes even numbers as even, that when they're divided by 2, there is no remainder. Similarly, if you get some odd numbers, you'll see that the pattern is inverted in a way, and you get 11 divided by 2, 27 divided by 2, and 3 divided by 2, and the remainder in all of these cases is always 1. For example, for 11 divided by 2, 2 goes into 11 5 times, you get 10, and then 11 minus 10 gives you a remainder of 1. So again, for every even number, the remainder when divided by 2 is always 0, and for every odd number, the remainder when divided by 2 is always 1. So we can use this knowledge to check whether any arbitrary number is odd or even. Let's say we've got an arbitrary number 37. This could be the user's age, or it could be the row number in a table, or something like that. And then we want to calculate whether it is odd or even. What we have to do is we have to get the modulus operator and calculate the remainder of this number when divided by 2. So we will say remainder equal x% 2. Now, notice that we've got this variable remainder, which we used earlier on. That's totally fine. This is just a variable name. You can call it whatever you want. You can even reuse a previous variable name, and that's fine. What we've done here is we've got the value x modulus 2, which is the remainder of the division, and we've said that the remainder variable that we created earlier is now a name for this value. So that just reassigns that variable. If we print it out, you'll see that the output should be 1. But before running, I'm just going to delete this code here. And now let's run this. You see that we get 1 back, which tells us this number here is odd. Think about this. Have you ever seen a table online where each row has a different color? So for example, the first row is gray, second one's white, third one's gray, the fourth one's white. So you've got like this sort of pattern. This is a perfect example of where the remainder, or being able to calculate whether a number is odd or even, comes into play. They are probably using this to only target the even rows and color them in a gray background. Throughout the course, we may also encounter other instances where this can be useful. But that's it for this video. Thank you for joining me.